Well, welcome to the Composable DXP with Uniform Bootcamp course, lesson number 3, Separation of Concerns. Today presented by Tim Bennix. He's the Principal Developer Advocate at Uniform. If you want to learn more about him, we have a great interview with him in the introduction section of this bootcamp on headlesscreator.com. So just go there and check it out. Now, with that said, I'm going to bring Tim in. Tim, welcome. I'm going to let you get started. If anybody has any questions of the live audience, type them in the comments and I'll ask Tim. It's all yours, sir.
All right. Thank you very much. So today we will be talking about the separation of concerns. And that's a term that keeps coming back. I guess for my whole career, I've been talking about this stuff from being a front-end developer or maybe somebody who works on teams and things like that. It keeps coming back. And so in computer science, separation of concerns is a design principle for separating a computer program into distinct sections such that each section addresses a separate concern. And so this is the opposite of the spaghetti code you might have heard about back in the day. And so today I want to talk about this and how that actually works in general, but then also how it applies to DXPs and to being composable. And so let's talk about separation of concerns with a bit of a real life example that will hopefully make it a bit more tangible. So not super codey and techy, but imagine you have a hospital, right? There's lots of different disciplines and departments in a hospital. If they didn't have separation of concerns, everybody would do everything. But a nurse cannot do what a doctor does, and a doctor cannot do what a cleaner does, and a cafeteria person cannot do what a doctor does, but they all have their own amazing skill set. And so you have to separate the concerns and then hopefully get an organization that is scalable and easy to oversee because you know who does what and when and how and where. And part of that separation of concerns has something we call cohesion and coupling. And basically what you're trying to do with separation of concerns is try to reduce the coupling and try to increase the cohesion. So let's have a little talk about what these two terms actually are. And pay attention, those will be important words to remember for later on in the bootcamp. So when we look at cohesion look at this lovely image here. I love this one because basically this is separation of concerns because the forks and the spoons and all the other things, they are actually separated, but they are also chunked up together in things that are similar, right? And that's what cohesion actually is, right? So cohesion is a measure of how related individual items in a group are kind of like how they are related to one another. Because if you go without cohesion and you just have everything separated out because, separation of concerns, it can be quite messy. So think about code for, let's say, calculations, right? You might have a function for plus, and you might have a function for minus, and you might have a function for other calculus things. Well, wouldn't it be easier if you grab these functions, you put them in a class, right? And then that class becomes your math class, and then you can reuse that everywhere. So you have actually put things together and you made them a bit more cohesive, and then you use that as something in your system. And so now let's talk about coupling. And you can see this, I love this image, right? This is a pretty tightly coupled system. And I also love that there's an air fan on the side that is completely futile because that's obviously not going to do anything. But aside from the image, let's have a little think about what coupling actually means, right? So coupling is a measure of dependence between two or more components. Tight coupling is bad and loose coupling is good. And of course, in the context that we're talking about now, because loose coupling is great, but if it's too loosely coupled, like what we said, if all the forks are on their own and all the spoons are on their own, it's really hard to actually deal with everything, right? So you kind of have to find your way, balance between the most loose coupled stuff you can get with the most amount of cohesion that you can get. And that's what we're looking at. And this applies to hospitals, like we just talked about, but also to code and to DXPs and many other things, right? And so why is this actually so important? It's kind of an interesting story, right? But why is it so important? Why is it applied? And so, well, what you want to look at is, if you remember the disconnected sandwich from the last two episodes, this is again one of those, right? So all of this separation of concerns gives you is actually having better clarity, right? It's easier to understand what's going on when everything is neatly organized. This is kind of obvious, I guess. But all of those are honestly open doors. But when you put them all together, it's like, that's separation of concerns. And that's why I want it, right? Because reusability becomes much easier because it becomes easier to extend or to fix or change when things are better organized, right? And you can also test things much better, right? Because when everything is isolated, um, you know what one chunk will do. And if you don't have that chunk and you're going to have to test something else, you just mock or fake that other chunk. And then you don't have to have that in your whole system of testing. No, you just say, okay, I'm going to test 1 out of 8 things. So the other 7, I'll just fake them to make sure that they exist in the software, but they always give the same output, let's say. And so that one thing you want to test doesn't now break due to all these other 7 things doing stuff. So it gives you much easier way to test things. And if you want to create new features or scale things up or change things up, it's much faster in development if you just have a nice overview. And organizational as well, right? If everything is neatly separated, it's so much easier to actually have a good overview of what does what and when does it and how does it do it. And wow, that was not English, but I guess you get the gist. And so there's a couple of important things of why this is so important. And so now let's get to the meat and potatoes of this talk. We're talking about DXPs here, right? And so how does this separation of concerns actually align with DXPs? Well, building a technical stack from composable products doesn't actually mean that you end up with a composable architecture. There is kind of a big trap here that you can fall into when you think everything is composable, and then actually you put everything together and you build your architecture, and suddenly it's no longer composable because you didn't separate the concerns well. And we'll talk about how that works in a sec, right? So in the traditional monolithical systems, like the old school stuff, basically, is it's basically a collection of capabilities from a single vendor that are by design interconnected and indivisible, right? So traditional systems have interconnectivity because you have to be able to log into one system and deal with all of them at the same time. And you're not able to just remove one thing, or if you don't need all of it, don't take these. It's the whole goal of this monolith to do everything for you. And there's lots of amazing use cases why you would want this. But the moment that you don't want it, that you actually want to choose yourself what to do, suddenly it's actually pretty annoying that it's interconnected and indivisible, because you might want to take something out and suddenly something else breaks. And a monolith, that's a feature. It's fine because you're not going to take it out anyways. But when you go composable, you will. And so it comes down to the fact, if you buy a bunch of composable products, it gives you the potential to have them connected. But out of the box, they are not connected at all. You actually have to compose them together. And that's actually pretty tricky. So basically, you are the composer, right? And making integrations is actually pretty hard, especially to make sure that they are loosely coupled in a cohesive way. And so if you want to compose things really well and easily, you require an integration that is easy. But making an easy integration is basically the hardest thing to do. And so there's kind of this complex system going around. And because of all of these things, generally what you get, and this might be a little bit of a new term, it certainly is to me, you are actually creating a composable monolith now, right? Because it's actually a collection of capabilities that you select from multiple vendors, but they are suddenly also interconnected. because you have chosen to do it a certain way because of early stage decisions, or maybe not having an overview of everything and you just have to build it, and then this kind of stuff happens. And if this happens, they will also not be divisible, they will be indivisible, and you see all the locks appear. And if you have this, how are you going to change your front end, or how are you going to change your commerce engine if they're connected to everything? So you have possibly now created something worse for composability than the monolith is. Because in a monolith, you can point the finger to one company and say, that's broken, fix it. In this case, who do you point the finger to? You connected them on their own, they work fine, right? And so you have to do everything you can to make separation of concerns a thing and not create a composable monolith, because it will be harder for you to move forward now. And so it's almost like, okay, let's do Legos, right? Because it's also nice and composable, but then you use super glue to glue them together. So I will hereby propose to you the new brand image of the composable monolith with Le Glue. And this literally a bucket of glue next to Legos, right? And you don't want to be gluing Legos. And I know Lego glue actually exists for the more professional Lego builders. I know, but the image still works, right? And so, what is truly composable?